So 9.1, we're looking at, for the first part here, we're looking at different sets. We're going to look at union and intersection. And the first thing you've got to get with union and intersection is basically the symbols they're going to use for this part. For union, we've kind of looked at that a little bit already when we did some interval notation. That union, that's the symbol for it's going to be just a U. And with that part, when it's the union, it's the combination of the two things. That when I talking about the union or the different parts of it here, union is anything that goes. Doesn't matter what it is. Anything that's in that set, that answer is going to be there. When you talk about the intersection, for that one, they're going to go the opposite. They're going to give it upside down. And for the intersection, when they talk about here, it's the elements that are in both sets. Again, element or elements. Most time it's more than one, so most time it's a lot of elements. So it's going to be the element or the elements that's in both sets. And sometimes for that one, that's where they'll kind of tell you, all right, this is the overlap. Especially if you start looking at graphs, sometimes with those, graph-wise especially, they're going to talk about finding the intersection. That's where you would lay the two graphs on top of each other on a number line and tell me, okay, where do both of the parts get covered when you're going through this thing. Now, when they start off with this one, not doing any graphs, this is where they'll just give you a small set of numbers. And they'll tell you that set B, capital set B, is going to be A, F, and G. Capital set A, we're going to go with E, G, and H. And they should ask you to find both of the things. So they're going to ask you to find the union and the intersection of A and B. And we'll change the color on this one so we can see it stand out a little bit more. And a lot of times they'll give it to you like this. They'll tell you to find A union B. And again, if you're doing the union, it's anything that's in any answer that's up here. So you've got A, F, and G. Start off with those three because that's in the first set. And do the same thing in the second set, but you've already got the G here, so you don't have to repeat it. So then you can say it's A, F, and G. From the second set, we already had the G that we used, so now we just got to use E and H. And for A intersect B, well, now it's just tell me what's in both sets. So the only thing that we had here, and basically it's what we said a minute ago, is since G was here and here, we didn't have to repeat it twice. So for that one, your answer would just be G, because that's the one thing that's in both sets there. Okay, and sometimes when you get the letters, it throws people off, so let's give you one where you've got some numbers, and we'll do the same thing here. Okay, so for this one, H will be -1, 1, 2, 4, 6, and then M would be 3, 4, 5, 6, 7. And the order, and when you're doing the intersections or the union, it doesn't matter which one they give to you first. So for the first part here, we're going to do M union H, which looks like M, but anyway. So you want to find anything and all that's there. List every single number that shows up, no matter where it is. So we've got -1, we've got 1, and the order shouldn't matter as long as they're all the numbers there. The order does not matter. We had 2, 4, and 6 in the first set. Well, once you've listed 4 and 6 here, you don't have to use the 4 and 6 in that set. So then we're going to do 3, 5, and 7. Okay, for intersection, well, once you get parts that repeat, that's the numbers you're looking for, because the 4 was here and here. Same thing for the 6, it was here and here. So for that one, it would just be 4 and 6. And which letters first, it doesn't matter. Intersection or union, it's still the same thing no matter how you set that part of it up. Okay, so they go from just giving you 4 or 5 numbers or 4 or 5 letters for this part of it, and then they start going one more step beyond that, that now they're going to give you a range of numbers. So this time they'll tell you that set A, and they give it to you in set builder notation, which basically just means that they repeat the X value 2 different times. So instead of just giving you X greater than 4, which is normally the way we would do it, they're going to give you the X with the slash through it, and that just means you're using X variable such that X is greater than 4. It doesn't really mean anything different, it's just a different way of notating it there. And for B, we're going to do X so that it is less than or equal to 7. And we'll do the same thing. We'll do A union B, and then we'll do A intersect B. Now, here's where they're going to make you kind of tie this back into a graph. So what you want to do is go back almost to like a number line kind of thing. You've got 4 and 7. So here's 4 and here's 7. And just graph those 2 lines on a number line. See what happens with it. So you want everything greater than 4. So that would be an open circle here. And if that's 4, we're headed this way. And if you start at 7, well, that's going to be a solid circle here, and that's headed that way. And then after you put those 2 lines on there for union, it's pretty much lay the 2 lines out there. What's covered? Everything, right? Because the blue line starts here and heads off to the right. Green line starts here and goes left. So when you cover it, you've covered everything from negative infinity to positive infinity. So if you cover every single answer there, that's going to be your answer. You're going to tell me that's negative infinity to positive infinity. for that one, we didn't talk about that. If there's a bar underneath it, like this one is, that's going to be solid. If there's not a bar underneath it, then it's going to be an open circle. So that'd be a good something to put on the side over here. So if you have x less than or just x greater than, that part's going to be an open circle. And if you do x greater than equal to or x less than or equal to, that's when you're going to use a solid circle. Now, and that one ties back in with interval notation that if it's an open circle, you're supposed to be using a parentheses. If it's the solid circle, then you're going to use the square bracket. When you bring it, because you're going to go basically two things. You're going to graph the points that's here, and then at the same time, you're going to take those points and then put it back in interval notation. So you could almost, when you're graphing these, if they don't ask for the graphs, if they just ask for the answers on these, you could almost go back and kind of have this question written like this. This would have been a solid parentheses here, because you got the solid circle. And then this graph would have started with parentheses going that way. So you could almost just kind of not even worry about the circles and just go back to parentheses and brackets on those. Yeah, so that one was the union. Now we'll go back and do the intersection. Now, and if you've got the graph, you can almost basically just go back and copy that exact same graph that you've got. We started at 4 here and went this way. We started at 7 and went this way. And again, if you've got this is one of those where if you're graphing these, if you use two color pencils, it really works out pretty nice for this one. If you could do a yellow marker and a green marker, graph the two, and wherever it turns green, like yellow and blue, sorry, if you did a yellow marker and a blue marker, graph those two things together. Wherever it turned green, that would be your intersection. So for this part, we're going to go kind of opposite here. This would be the intersection we've got right here, because there's a yellow and the blue line. Sorry, blue and a green line. Get it right here in a minute. There's the green line and the blue line. That's where they would cross, and that's what intersection is. It's where do they cross. So for that part, and here's where if you use the brackets and the square and the parentheses, that answer would be 4, 7. So where you've got the open circle, that means you're going to use parentheses. Where you've got the solid circle, that's where you're going to use square brackets. So you could almost graph those using those square brackets and parentheses instead of the open circles and closed circles. When they explain it, if you look through any examples that's in the online homework or the textbook, they're going to use the circles. But really, they should go ahead and start using the parentheses and the brackets just to kind of help you walk through those. Yeah, you want one more of those? Just make sure we got it with the graphs. Everybody sounds excited, so sure, let's do another one. So this time let's go with set A is W such that W is less than 1, and B will be W so that W is greater than or equal to 7. Okay, so for this one, we'll go A union B. And sometimes this is the easy one to do, sometimes it's not. It just depends on how the numbers are laid out. But most of the time, this is one where it's pretty easy. You label whatever the two graphs are, put them on one number line, and then just see what you have. So for this one, we've got W is less than 1. And again, because it's just less than, that would be an open circle. But just so we can see it in interval notation, we'll use the parentheses. You want everything less than negative or less than 1. And for W greater than or equal to 7, we'll start here. This time we're going to use a square bracket, and it's going to go that way. And again, if you think about it, that when you're graphing these, that this sign has to match up with that arrow. Same thing for this one, that this sign will have to match that arrow. So the sign should always match the arrow, how they're drawn for this part. And for union, that's it. That's your answer if they ask for the graph. Now, they're going to ask you to put this answer in interval notation without the graph. So then just tell me the numbers. This one goes to negative infinity. You get to 1. You've got the parentheses here, so go ahead and put the parentheses here. And you're just going to put the union. You've got the square bracket here, and chase that off to infinity. Again, infinity or negative infinity, you never put the square brackets on it. They're always parentheses, because you can go, whatever number you give me, somebody can give you one more than that. Give me another number, we can give you one more than that, so it never stops. Now, if you use that one graph, if you got it with the two different colors, it should make things a little bit easier here. With the intersection, where did the red graph and the green graph cross? They don't, right? They don't touch, because the red starts here and goes left, the green starts here and goes right. There's nothing there, so that one would basically be that there is no solution. Or no overlap, no intersection. I think even on this one, they tell you, but sometimes they even call this an empty set. And sometimes they'll even just give you a shortcut and give you a 0 with a slash through it, saying, all right, there is no answer for this thing. And that's one of those where in the homework, that would be an option that they would give to you, this a totally separate option. You just click on that button. Okay, so that's just the different options. Sometimes you get all numbers, sometimes you get no numbers. Sometimes you'll get just a range of, from one point to the other as you're going through those. But that's all the different options you'll get when you're looking at the different things you can do for union and intersection. Okay, and then they'll use that to kind of walk you into solving equations, working through some different parts on it. But for this part of it, because of the less thans and the greater thans, they're going to ask you to solve some compound inequalities. And for the compound inequality, that just means instead of it being one equation, or in this case one inequality, it's two parts. You've got two parts you have to worry about graphing wise. So for your answers, if we were to put them on a graph, it would look similar to like this. You may have one answer that goes off to the right and one that goes to the left. It could even be that you've got, like we had on one of the earlier examples, where you got two graphs that went across in the middle, and you've got some different things in between. So they kind of throw this one out here and say, well, we're going to use that to kind of tie in with the unions and the intersections on this. And basically, you've got two types. The first type is what they would call an AND graph. So with the two types, you've got an AND inequality, or you have an OR inequality. And that's your two types you're going to have. And for this part, they'll kind of introduce it a little bit here with what we've got in Chapter 9. We'll come back later, add a little bit more to it. But generally speaking, if you can kind of put it into general speak on this one, if you have an and statement, usually those answers are going to be sandwiched between two numbers. Now, and there's always exceptions to the rules where sometimes you get a weird equation or a weird inequality where it's not quite always sandwiched between two numbers. But most of the time, here's why I like to say it this way. If you have an and statement, it's sandwiched between the two numbers because you've got the and in the sandwich, so they go together. That most of the time when you get finished, you're going to have more like an overlap, where it's going to be sandwiched between 4 and 7, or it's going to be between -1 and 10, or something like that. So generally speaking, you're going to have everything answer-wise should be between two numbers. If it's an or statement, again, generally speaking on these, usually the graph looks like the oars on a boat. And again, there's always exceptions to the rule where sometimes it doesn't work out this way, but most of the time, if we have an or statement here, it looks like an or statement there. And again, if you think about what the oars on a boat looks like, so most of the time when you're sandwiched, you're going to have, oh, not that one. Most of the time you're going to have it so it's sandwiched between two numbers, something like this. Now it's almost like your buns that you've got there. You can here's the buns on the end, here's the meat in the middle. Or if you're vegetarian, there's the lettuce in the middle. And oars on a boat most of the time. When you get finished with this one, what do the oars on the boat do? They start on the edge and they go out in the water, right? So most of the time you're going to have something that like this, where one goes this way and the other one goes that way. Now, again, there's always exceptions where they don't always do that, but if you want to put it in what they usually look like, that's usually what they look like. That if you have an and statement, it's between two numbers, or statements, it's something off to the left, and then something off to the right. And occasionally, again, you'll get some things where it's not that way, but that's kind of the basic general ideas of what you look at. Okay, so let's give you a couple problems where you can see some different examples of how this looks. Okay, for the or statement, let's get you an or statement first. Let's go with 4x minus 6 greater than -2. And with the or statements, or will always be in there. And when we do the and, it's 50-50. Sometimes it is and sometimes it's not. Or, let's go with -2x less than or equal to -10. Now, the good thing about the or statements is those are two totally separate questions. And you can just put a split right down the middle and solve those two equations and just do them two totally separate ways. So for what we've got on the left-hand side, for this part, you would add 6 to both sides. You've got 4x is greater than 4. Divide both sides by 1. Sorry, divide both sides by 4. You've got x greater than 1. On the right-hand side, only one thing to do. You've got to divide both sides by -2. Now, here's where we've got to add in one little thing. So this is kind of why we got this one number that's here. There's only one time you have to worry about changing your less than and greater than signs. And that's right here. That if you multiply or divide by a negative number, So if you multiply or divide both sides by a negative, that's the one time you have to change your inequality sign, your less than or greater than sign. So we'll just say flip your inequality. Okay, so for that one, and again, that's the only time. Any other time, if you're adding or subtracting, you don't ever change the sign. If you're just doing distributive property on one side, because sometimes you'll get a problem where you've got a -2 that you're going to multiply on this side, and it's greater than 14 or whatever the number is. If you're doing distributive property just on this one side, you don't change the inequality sign. It's only if it's on both sides when you've got to change that inequality sign. So when we divide by -2, that means we're going to change this inequality sign from being less than to being greater than or equal to. And when we divide -10 by -2, that's going to make it a +5. Okay, so we had, oh, actually, hang on back up here. I wrote down the wrong sign. Sorry about that. Change that one sign. Let's change, oh, stop moving. Change that sign we had back here to being less than, because I had written that one wrong. It's supposed to be a less than, my bad. So if you finish those two things off, we had x less than 1, or we had x greater than or equal to 5. And you don't have to graph these, but for sometimes people like to get the graphs so they can just see how it lays out. That one you would start at 1 and go to the left. And again, because there's not a bar underneath it, let's do the parentheses here. So we go that way. For the 5, well, you start at 5. This time it's a square bracket, and it's going to go that way. And the OR is basically the same thing as the union. So when they're talking about the ands and the ORs on these, that's what an OR statement is. It's the union. You'll take either one of the two. Doesn't matter what the answer is. So if they ask for this in interval notation, you're going to start at -infinity. Go up to 1 with a parentheses. We'll do the union, start at 5 with the square bracket, and then take that out to infinity. Okay, so when you're doing these, the OR statement, that's going to be your union. When we do the AND statement, that's going to be your overlap when you go through the different parts of it. Okay, so there's one that's an OR statement. Let's get you an AND statement. So let's go with 4x. Make sure I get my signs correct on this one. 4x minus 5. Let's go less than 15. And we've got our AND. 2x minus 3 is greater than 1. Okay, and the signs are correct on this. Okay, and when you see the AND statement, that's one where you can basically think, all right, that's an intersection. We've got to find the answer that is the overlap of the two graphs if we were going to graph these. But you still kind of, as long as they give you the and statement here, still solve as two separate questions. So on the left-hand side, we would add 5. So we've got 4x less than 20. Divide both sides by 4. Nothing's negative, so we don't have to worry about flipping these signs. That's x less than 5. Right-hand side. Still pretty short on this one. We're going to add 3 to both sides. We've got 2x greater than 4. Divide both sides by 2. That's x greater than 2. Okay, so this one was an and statement. So for this part, we're looking at the overlap between those two. And again, you don't have to do the graph, but a lot of times it's just a good visual to kind of get an idea of what you're looking at. So if we do x less than 5, starts here, that one is less than, so that would basically be a parentheses headed in that direction. Now if we go x greater than 2, that's going to start here. That one also is going to be a parentheses, and we're going to head in that direction. So we've got the green going there, and we've got the blue going there. So where you've got the green and the blue overlap, green and blue make red, right? That's everything from here to here. So for that answer would be from 2 to 5. Okay, so when you're reading through those, that's the two big things. That when you see an and word, that basically means that it's the intersection. Whenever you see or, that's going to be the union. Now, and again, most of the time when you're talking about those, the and statement, usually it's going to be between two numbers. The or statement, most of the time it's going to look like oars on the boat where you got something on the right side, something on the left, you got this gap in the middle. But there's always exceptions where when you do some of these problems, you may get something that's a little bit off, where the points don't quite match up. So you can always get the different parts where there's always something a little bit different that may happen. Okay, now before we show you one of those where it's a little bit different, let's get you one more and statement that's a different way of looking at an and statement. So let's go with 6 less than 3x plus 3, which is less than or equal to 15. So here's one where they don't give you any words. It's just, there's no and, there's no or. That when you see one like this is basically an and statement, even though the word's not there. That it's basically two parts. The and part of it is that 6 is less than 3x plus 3. And then it's and that same 3x plus 3 that's in the middle is also less than or equal to 15. So they've again, to borrow with the word there, they've sandwiched it all together. They took the two separate parts and just made it into one long part when you do this one. Now, you have two options. The longer option is you solve this equation and work it out. You solve this equation, work it out. Go back and graph the two things and see where it is. Okay, you can do that. Here's the shorter option. Take what we've got in red, and we're going to solve both equations at exactly the same time. And you may be saying, well, how are we going to do that? Well, just if you kind of stop and think about it. If you were going to solve this one, what's the first thing you would do? Subtract 3, right? Subtract 3 from this side, subtract 3 from this side. If you solve this equation, what's the first thing you're going to do? You're going to subtract 3. So instead of doing the exact same thing two separate times, when you subtract 3 on this one, subtract 3 from all 3 parts. Because you would subtract 3 from the 6 and from the 15 and from the middle, so just put it all together and subtract 3 all at the same time. So that's going to be 3 less than 3x less than 12. Okay, so if you only had one of those, what would be the next thing you would do? Just divide by 3, right? It's the only thing left to do. So for this one, the same thing. Now instead of just dividing that part by 3, you're going to divide all the parts by 3. Because that would have been the next step back up here. Once we had this down to 3 less than 3x, you would have divided by 3. Same thing with this one. We'd have 3x less than 12. You still would have divided by 3, so let's just do it all at the same time. So that 3 divided by 3 becomes 1 less than x less than or equal to 4. And that way, now you've almost got the answer in implementation just like that. Here's where you don't need the graph for this one. From what we said just a minute ago, is if we were doing this one, if we had just the less than, that was a parentheses. So for this one, just take out the less than and think of that as a parentheses. We've started with 1. We're going to 4, and 4's got the less than or equal to with it, so you put a square bracket on it. So if it's all sandwiched together, once you solve it, that's the beginning and that's the end, and you use either a parentheses or a bracket based on whether you have the bar underneath this or whether you don't. And that way you don't have to graph this one. So that one's actually, if you get used to that, one's actually better because there's no graph needed. Once you've got your two numbers, that's your two numbers in interval notation.